Okay, gang, let's get started. Okay, so happy Wednesday. Today is our 29th class. We are covering more related rates. This is our second day on related rates. We are going to have a third day on related rates coming up. I think it's, when is that? Like right before the Thanksgiving break. Related rates in-class quiz. We'll talk about that later. Also coming up on Monday, I will hand you our fourth take-home quiz. You will take it, and then you will give it back to me on Wednesday, okay? Any questions on the calendar? All right, and as usual, hopefully we're working on the two projects, data and rainbow. They'll be coming up due right after the break, Monday and Wednesday, right after Thanksgiving break. Okay. So today we'll continue to work on related rates problems last seen 2 classes ago. So we're gonna do one problem here together in the demo, and then you're gonna spend the rest of the time continuing to work on the homework for related rates with each other. If you finish that during class, or if you have finished that already, there are more related rates problems just on the next few pages in this packet. All right, so something for everybody. And so then finally on Friday is when the related rates assignment will be due, okay? But hopefully many of you will have it completed by the end of this class. All right, here we go, our one problem together. Ship A is sailing north and ship B is sailing east. Let's go ahead and label here. So A is this guy going to the north and B is this one going to the east. Using an XY plane, radar records the coordinates of each ship. Approximate the rate at which the distance between the ships is changing at t equals 5. All right, let's see if this picture makes sense to us. So ship A here, it's got various moments in time, 1.25 minutes after we started this experiment, 2.5 minutes, 3.75 minutes, and 5 minutes. And it says the x coordinate for the boat is 1.77 for all of these. And the y coordinates are the things that are changing. And so at the earliest time that we have recorded, the y coordinate is 2.64. So I guess that's this one right here. And then a minute and 15 seconds later, it's 2.97, and then 3.42. And then finally, the last recorded data is this last point up here. So I'm going to go ahead and draw an arrow here. This is ship A going due north, okay? And you can check the data on the other one. What's constant for the ship over there? The y value is always 1.24, and then the x's are getting bigger, so I'll just put an arrow here. That ship is heading to the east. And what we're interested in is the rate at which the distance between the ships is changing at this last moment that's recorded. It's the same moments in time for both tables. And so I guess that means we should draw something in. What should I draw in? Like a line connecting what? Which points should I, like I've got, yeah, like the 5-minute points, the points that are the focus that we're interested in here. At t equals 5 are the last points that are drawn. So I'm going to draw this guy in purple here. And I'm going to go ahead and give this guy a label, like the length of that thing I will call C. And so the thing that we are interested in is the rate at which that length is changing, right? These ships are getting farther apart, and we want to know the rate at which they are getting farther apart. So symbolically, what am I making equal my question mark? dc dt, right? It's the rate at which C is changing as time passes. That's what we're interested in. Okay, so the reason that I wanted to do this problem is that it's the only one that we've seen together that has data. Like this is just information in a table as opposed to the, like lots of words describing certain scenarios. And so how do we handle it when we have just data and no formulas, right? Like we're not going to use like the volume of a cone formula. We have incomplete information, just 4 data points for each ship. Okay, well, we need to come up with an equation that has a C in it. I've got like part of a picture here, like I desperately want to complete that to make what shape? What kind of triangle? A right triangle, right? Like it's just very natural for us to complete this picture to a right triangle. So let's complete it down here over that way. Feels better, right? You can breathe now. And so how about we call this guy over here A and this guy over here B. Clearly A and B are changing, right? You can't put them as like constant numbers. They're both getting longer as these ships move north and east. And we need an equation that relates A, B, and C. What is it? It's a Pythagorean theorem, right? So that's the equation we pull out of a hat. A squared plus B squared equals C squared is our equation. Now, oftentimes we have like other values that are given in the problem, like maybe A is equal to something or B dt is equal to something. Well, I don't really know what I'm after yet. So we're doing this one in a kind of different order. We've got our equation. We're going to take a derivative of both sides of that equation, and then we're going to look at what we need in order to like solve that final thing for what we're after, the dc dt. Hunter?
Set it up, by the way, like
Yeah, that's a good question. So Hunter is wondering about using this alternative version. What do we think? Is Hunter's equation equivalent to ours? You bet it is. Which equation would you rather take a derivative of? The first one, because the second one involves the chain rule, right? Stuff to the half power, half comes down, copy the stuff, negative 1/2, and then the chain rule pops out of that. So absolutely, Hunter, you'll get the right answer using this second equation, but I would certainly much rather use the first one. Okay, so let's take a derivative here. What is the like ordinary derivative of a squared? It's just 2a. But this is no ordinary a. This is an a that changes based on time. Time is the underlying variable. So it's not just 2a, what is it? 2a times dA dt, right? That is the chain rule. That is the derivative of the stuff. A is our stuff. A squared is really stuff squared. Okay, and then plus, now we're doing the derivative of b squared. What is it? 2b, but then times dB dt. And then that's equal to 2c dc dt. And at this moment, I feel like I'm making progress because after all, the purple question mark up there says, what is dc dt? Well, that's one of the things in my equation, right? Unfortunately, there are a lot of other things in my equation that I don't currently know the values of. But this is our task, is to find values of everything else in that equation. And then ultimately, this will unlock the variable dc dt. Okay, so before we do that, I like to clean up my equations if I can. What can I divide everything by? 2. So you don't have to do this, but it just makes it a tiny bit easier. So divide everything by 2. Okay, so let's focus on the 5 things in that equation that we need to substitute for numbers, right? There's six unknowns in this equation. A, dA dt, B, dB dt, C, dC dt. One of them I care about, dC dt. The other 5 I'd better be able to like fill in with numbers right now. So let's start with A and B. Is there a way to know, like it looks like they're changing in this picture, but at the static moment when t is equal to 5, because that's what we're focused on, at that static moment, it is this triangle, like specifically this one that I've drawn, and it's locked in. So how would we calculate from the table the value of A? Yeah, it's whatever this vertical change is. Well, how much is the y coordinate at the top? You have to look in the table. 3.67, right? That's the top y value. How much is the bottom y value? It's 1.2. You have to look in the other table for the bottom, right? Like the bottom y value is the y value for all 4 of these b points over here. That's a 1.24 at the bottom. So this is really sneaky. So this is let's write it here. So we've got, what did we say it was? 3.67 at the top, and then 1.24 at the bottom. That difference, that's our a value. So looking at those 2 things there, a equals 2.43. Okay. All right, so far so good. Can you hunt around in the table to find b? It's the same idea. Just have to look carefully for the right numbers to calculate b. Is that the final number? Let me write down the intermediate ones. So what's 6, 6.08 there, and then 1.77 there. We buy that? Right, and then we subtract those. Get B is equal to, what is it? 4.31. Okay, so we've got our A and B at this particular moment in time, this fixed picture moment. How are we going to find C? Wait, we can't use the tables. I mean, the tables don't tell us. Yeah, we've got that green equation right there that tells us the Pythagorean theorem is true. And so we just plug our particular A and B into that equation and find C. So let's do that. So I'll write it down here in green. 2.43 squared plus 4.31 squared gives us the C squared that we're interested in. 24.48. Okay, so that's the C that we're interested in, 4.94. That make sense, how to find that particular C? Okay, so let's regroup here. I had this bottom orange equation. It has 5 things in it that I need to replace with numbers and 1 thing that it's going to solve at the end of the day. So this dc dt, that's our question mark. I'll just put the question mark over there. We currently know the values of A, B, and C. All of those are going to get substituted in here. So I'm putting check marks on A, B, and C. So what do we still not know about, but we need to know about? dA dt and dB dt, right? If we can just find these last 2 pieces of the puzzle, we're done. So how are we going to find the ADT? All right, let's take a look. A, remember, was the vertical side in my triangle here. And I'm interested in the rate at which that vertical side is getting longer as this boat goes due north. I have very little information about this boat. I have 4 data points about this boat. I'm interested in the rate of change, like the speed of the boat as it heads north. Yeah, all we can do is use points that are use numbers that are near what we're focused on. So for sure, at t equals 5, I need to know that it's at a 3.67. I'm interested in what is it at 5.001? I'm not going to get that information. The best I can do is use what other point in this table? The 3.75. I mean, that's the nearest point that we have. Let's just assume that whatever the boat was doing in that last minute and 15 seconds, it's going to continue to do right there at t equals 5. That's all we can do. So what calculation am I doing with these 4 numbers here? It's the difference quotient, right? It's the change in the value of A over the change in time, dA dt. Let's calculate it. All right, here we go. dA dt is roughly, it's our best guess. Well, I mean, it's the difference quotient, as Aaron says. It literally is telling us to find the change in A and divide by the change in T. So the change in A, what are the A's that I'm subtracting? And I'm dividing that by the change in time. That's it. All right, anybody have a final decimal for me here? I'll get some units just to lock this one in. Units for the derivative are always the dependent units over the independent units. What are the units for A? That's miles. What were the units for T? Minute. So that is 0.2 miles per minute due north. Okay, see if you can do the same calculation for dB dt. Again, we're focused on t equals 5, so you're going to use the same 2 points. In the other table, the last 2 points. Okay, who's got a final number here? 24 miles per minute. Question doesn't ask this, but hey, we just learned that ship B is moving a little bit faster. At least that's our best guess, right? At this moment, ship B is moving a tiny bit faster than ship A. Okay, and so I think we now have all 5 of the things that we needed. So let's plug all of these numbers in and get our final answer here. Okay, so A we discovered was 0.2. Sorry. A was 2.43, and the ADT is the 0.2 we just found. Plus B is the 431 times the BDT was this 0.24 equals C, or C, 4.94 times our unknown, which we will just write dCdt. So we do the arithmetic on the left, divide by the 4.94, and anybody has a number, we'll write it down. Again? So at this one moment in time, our best guess is that these ships, the distance between these ships is increasing at 0.3 and change miles per minute. Does it make sense? Like, so our two individual rates were 0.2 miles per minute and 0.24 miles per minute. Suppose instead of going north and east, they were going north and south. What would the rate of change be if they were, one was going north and the other was going south? The sum, right? It'd be 0.44, like clearly, right? What if they were both going the same direction, just one is a little bit faster? What would the distance be? The difference, 0.04. Anything other than these two extremes, going opposite and going the same, has to be something between those two extremes, like 0.44 and 0.04. Yeah, 0.3 is reasonable. I mean, you know, like it's not, it's closer to the 0.4, but you know, it's not. Yeah, so I mean, it seems like a reasonable number to me. All right, any questions on that? I wanted to do this one again because it's got like data tables, and also it's pretty tricky. I mean, like there was a lot of really heavy duty thinking that went involved, and we were kind of feeling around in the dark for a while. Like we didn't start by saying, oh, we better figure out right away what A is and what B is and what dAdt is. Like we didn't start there. We ended there because we let the equation, this derivative equation here, guide us, right? Okay. All right, so on the next page, this is just a repeat of what I said. You are going to continue to do the homework. Some of you are in very different places on the homework, so try to sit near people who are working on the same problems as you, okay? Don't necessarily have to stay at your table. So the homework is there, plus there's one problem from your textbook. If you have finished the homework already, or if you finish it during the rest of class, just start in right here with number 2. I think there's 4 related rates questions for you to work on. Daniel? I think I didn't write it because it depends on which edition of the book you have, but it's in the homework, it's in that one homework page. The priority is the homework, and only if you finish the homework should you jump in on the activities.